So here we have again the graph of insect abundance that we created earlier. So we have points for each sample, and we have a line that represents the mean. So the mean for this treatment here is definitely higher than the others. There were definitely more insects in the water spender plants than the others for this particular sample day. But as you can see, there's also lots of data points high and low in each plant type. Like even though that this one, water spender plants had a lot of insects, this one here only had 5 insects in it. How can we know for sure that this average or mean shows a real difference, or could it just be by random chance? So to add a standard deviation to this graph, you can go back to the little toolbar and add standard deviation. This creates lines above and below our mean that are 1 standard deviation away. And it gives us a visual idea of how spread out the data is. And as you can see, our standard deviations are pretty big. They're really spread out. If all of our measurements were close together and the standard deviation was small, that means there's not much random variation. If that's the case, then the standard deviation lines wouldn't overlap, and most likely our results would show a real difference between these two different treatments. However, if the measurements are really spread out, kind of like we have here, and the mean or average wasn't that far apart to begin with, you might see a lot of overlap in the standard deviation. So 1 standard deviation above the mean definitely overlaps with our bars over here. It doesn't mean that our results are bad, but it does mean that there might be too much random differences to say for sure if our results are real. That could mean that if we went out on a different day and collected the exact same data, we might get a different result. When this happens, sometimes it means we just need to collect more data so we can get a bigger sample size, which we are doing. You are not the only 5th graders collecting this data. We have lots of students collecting this data throughout the spring. So looking at our insect abundance graph here, which was from February 2022, our water spender plants had the highest number of insects and non-native plants had the lowest, but our standard deviations are really big and there's a lot of overlap between these lines. For our results to be considered statistically significant, we don't want these bars to overlap, and ideally there might even be space in between them. But ours do overlap a lot, so it means the data from this particular day was not statistically significant. We can't be sure that there was a real difference in the numbers of insects from this day in February. Go ahead and add the standard deviation to your insect abundance and caterpillar attack graphs to see if your results were significant.